Hello everyone. In the previous video, we have completed descriptive statistics. Now we will start with inferential statistics. As discussed as discussed earlier, we have said that inferential statistics is basically that branch of statistics in which we usually find out some inference from our result. This mainly uses application of different kind of tests like t-test, z-test, chi-square test, ANOVA. All these tests we will study in detail a little bit later. First of all, we will start with statistical hypothesis testing. So, what would be the basic procedure for statistical hypothesis testing? It usually involves five major steps. First one is that we have to define an alpha value. We will discuss the meaning of alpha value after few minutes. Then second is describing the alternative and null hypothesis and null hypothesis. Third one is we will decide what test we want to apply. Which test, like t-test, z-test, chi-square test, which test we want to apply. Then fourth is we have to calculate the p-value or test statistics. Like if we are applying t-test, we will calculate t statistics. If we are applying z-test, we will apply z statistics. After calculating these values, we will conclude our result. These are the basic steps that we apply in all different kind of testing. So we will start each of the point and discuss about it in detail. So basically first is what is null hypothesis. Null hypothesis is usually represented by H naught. Another one is alternative hypothesis, which is usually represented by HA or H alpha, and null hypothesis also called by H naught. And what is the basic difference between null and alternative hypothesis? First is that suppose we have a condition, we have taken two different we have developed a new drug. Suppose we have developed a new drug, we want to test whether this drug is effective in this treatment or not. So we will compare it with anything, like any previously approved drug for that disease, which is called as a gold standard, or we will take any placebo, anything which we have to compare. So we have the data, we have our data like blood samples and all of these things. First, we will see, we want what we want to see. We want to see that whether the results we are obtaining from our drug are statistically significant or not from our placebo or any of our standard drug. So if the results are statistically significant, then only that drug would be useful. So for that, anything which we want, like we want to prove it statistically significant differences, we will call it a alternative hypothesis, and opposite to that is called as null hypothesis. One more thing, if we want to prove any two things are whether they are different or not, like we want to compare whether these two means are different or not, or whether these two variances are different or not. So null hypothesis would always be that the mean of A is equal to the mean of B, or the variance of A is equal to the variance of B. And alternative would be their variance would not be equal or their mean would not be equal. Or if in case of some treatment case, the null hypothesis would be that there is no significant differences in these two comparative values, and alternative hypothesis would be there are differences. So anything like like not equal to, they are not same, they are not statistical, they are statistically significant. All these things are our alternative hypothesis, and opposite would be our null hypothesis. So I hope this would be clear. Then after null and alternate hypothesis, one more thing is type of errors. So basically there are two main type of errors which we will talk about in statistics. One is called as type 1 error and another one is called as type 2 error. Type 1 is also called as false positive, and type 2 is also called as false negative. So we will learn the meaning of false positive. So a false positive, type 1 error. This means that our null hypothesis is positive. Our null hypothesis is positive. That means our null hypothesis is true. But we have said it is false. We have concluded that it is wrong. So this means that if suppose we are saying that whether our two means are same or not, our null hypothesis would be the two means are same, and our alternate hypothesis would be two means are not same. So if we are saying that in this case we have done a type of error which is called as for type 1 error, what does it mean? It means that our null hypothesis would be positive. That means our null hypothesis is true. But we have said that it is false. And we have said it is false. That means we have accepted our alternate hypothesis. It is true. And we have said it false. That means we have rejected our null hypothesis and we have accepted our alternate hypothesis. So I think this would be clear. Next, we will talk about type 2 error, which is called as false negative. So similarly, H naught, HA, H naught means A is equal to B, HA is A is not equal to B. This means that our null hypothesis would be negative. That means this is false. But what we have concluded by error, we have concluded that it is true. That means we have accepted our null hypothesis and we have rejected our alternate hypothesis. So I think this concept would be clear to you. This would be an important concept when we will talk about alpha value. So next we will talk about alpha value. Basically, what is alpha value? Before starting about alpha value, we will study about confidence interval. What does confidence interval mean? Confidence interval means that if suppose we have said the mean of our sample is, suppose it is 15, and we are saying our confidence interval is 2, and this confidence interval 2, we have to tell that at what confidence level. Usually it is 95% confidence, or it can be 99% confidence, or it can be 90% confidence. What is the difference between these three different kind of confidence interval? 90% confidence interval means that we are 90% sure that our population mean would lie in the value which we are saying. So this 95% confidence interval means that we are 95% sure that our result is falling in this range only. There are only 5% chances that there would be any outlier. And in case of 99%, we will say that we're 99% sure that our result would be following in this range only. So more is our confidence, like we are saying 90%, 95, 99. So 99% confidence interval means that there would be a less chances that we are getting or we are doing any type of error. So type of error like type 1 error, that is false negative error, that type of a false positive error, that would decrease as we increases the confidence interval. So if we are saying that mean is 50 and then 95% confidence interval is 2, that means our value lie between 5 plus minus 2, 15 plus minus 2, that is 13 to 17. So we are 95% sure that our mean value of the population would lie in this range only. There are 5% chances that our value doesn't lie in this range. So this 5% probability is basically what we call as alpha value. Fine. One more thing, this alpha value would be represented by this alpha sign, or we will call it a threshold p-value or significance level. So initially we have to decide what would be our confidence interval, that at what confidence interval we are giving our results. Mostly we will take 95% confidence interval, but in some cases where we want extremely right, extremely precise, and a very important type of result, like it should be true, the chance of error should be less. So in those cases we will take 99% confidence interval. So if we are taking 95% confidence interval value, that means there is just 5% probability that our values lie outside this range. So the alpha would be 5%, that means 0.05. And in case of 99% confidence interval, it means we are 99% sure that our value lie in this range, that that there are chances of false positive type 1 error would be only 1%. That means alpha is 0.01. Hope it is clear that what is confidence interval and what is alpha value. Another thing, there is a theorem which is called as central limit theorem. This type of theorem said us that if our data is like this bell-shaped curve, this is our mean and these are mean, which is represented by mu. Mu minus standard deviation, and this is mu plus standard deviation. Then another term comes mu minus 2 times standard deviation, and this is mu plus 2 times standard deviation. This is mu minus 3 times 3 times standard deviation, and this is mu plus 3 3 mu plus 3 times standard deviation. So what does it mean? That if we are saying that mu minus sigma to mu plus sigma, in this range we are 68% sure, like our confidence interval is 68%. If we are taking the range for mu minus 2 alpha to mu plus 2 alpha, that means this means we are 95% sure. And if we are saying that we have calculated the data we have is mu minus 3 sigma to mu plus 3 sigma, we are 99% sure. So you should learn these values, that if our value is mu plus minus sigma or mu plus minus 2 sigma, then mu plus minus 3 sigma. If we have this value, we will call it 68% confidence interval. and mu plus minus 2 sigma, it is called as 95% Ci, and mu minus 3 sigma, it is called as 99% Ci. That means if 95% Ci, that means alpha value would be 0.05. 99% Ci, that means alpha is equal to 0.01. This is the concept for central limit theorem. Next, we have completed alpha value, and we have completed null hypothesis and alternate hypothesis. Then next would be our p-value. What is a p-value? What does this mean? We have applied any test, we have calculated the t statistic, and we have calculated the p-value. If suppose we are saying that we are giving a result in 95% confidence interval, that means our alpha would be 0.05. So when we have applied any type of test, any sort of test like t-test, chi-square, any sort of test, the concept would remain the same. All these concepts of confidence interval, alpha, p-value, they would remain same in all kind of tests. So basically, what does p-value means? It means that we have applied our test, we have calculated our p-value. Suppose p-value comes out to be 0.02, or there is any chance that it comes out to 0.06. That means the same as alpha. It is the correspondence of alpha. We have to compare our p with alpha, and we will decide whether we have to reject our null hypothesis or we have to accept our null hypothesis. If p value come out to be 0.02%, that means there is just 2% chance that we have type 1 error. That is, we will tell the result as false positive, just 2% chance. But 98% chance we are sure our result would be fine. In case of 0.06, it is 6% of type 1 error. So when we are saying our result in 95% confidence interval, the maximum allowed error would be just 0.05. So if our error type of our type 1 error increases from 0.05 to any number, we would have to accept our null hypothesis. That means we would say our means are same, our variances are same, there is no statistically significant differences. But if our p-value comes out to be less than alpha, that means chances of type 1 error are less, and we will say we will reject our null hypothesis, means we will accept our alternative hypothesis. If we have accepted our alternative hypothesis, that means either the means are not equal, either the variances are not equal, or there is statistically significant differences in our result. So, generally speaking, if we want, if we have discovered any new drug, so basically what we want that our drug has statistically significant differences, so that we will prove that our drug is better than the already existing drug or any of the placebo drug. So for that, what we want that the p value should be less than our alpha, so that we can reject our null hypothesis and we will accept our alternate hypothesis, which will give us the result that there are statistical significant differences in our formulation. So this is what is called as p-value. Next one more thing. If suppose our if we are giving our result in 95% confidence interval, then if our value is somewhere near to it is less than 0.05, but it is somewhere near to 0.05, like 0.02, 0.03, 0.05, we will call it significant, that our result has significant, there are significant differences. But if the value decreases beyond 0.01 from to range 2.001, it becomes very significant. So the more and more our p-value decreases, more and more it will move away from our alpha value. We will tell that the results are extremely significant or they are extremely good results. Now we will just see some written notes. What we have seen.